We have one more graph to add in our discussion of domain and range and periodic function. We're going to show what happens when we extend tangent graph from -60 to 360. So first of all, we want to look at all the places where tangent equals 0. So we know tangent of 0 equals 0 because that's a horizontal line. Tangent of 180 equals 0 because that's horizontal, and also 360. And if we went the opposite direction, -180 and -360 would also have a slope of 0. So this is slope equals 0. Now, where is slope undefined? Well, that's any place where the angle makes a vertical line. So that would be at 90 and 270, and then -90 and -270. So we're going to put asymptotes wherever there is undefined value for tangent. Now we also want to know where the angle equals positive and -1, and these are at our 45-degree reference angles. So between 0 and 90, so let's kind of just look at our triangle again. So here's, or sorry, a little circle, 0, 90, 180, and 270, and think about slope. Okay, slope here is positive, quadrants 1 and 3. Slope is negative in quadrants 2 and 4. So we're thinking 45-degree angle in quadrant 1, that's 45 degrees, that's a slope of +1. Where's 45 degrees on my grid? Well, it's halfway between 0 and 90. So at 45 degrees, I'm up at 1. Now I would have really liked this to be 1, 2, 3, 4 like I did before, but we'll live with a scale this time. Okay, where else am I positive? Between 180 and 270, halfway between, that's 225, that's also 1. Okay, so at 45 and at 225. Halfway between 90 and 180, and halfway between 270 and 360, I'm at -1. So here and here, I'll be at -1. Now, I'm going to keep going into the other side of the graph here. So when I'm at positive 40, so positive, let's see, where am I? Here's a -45, which would be right here. It would be the same as positive 315. So -45 is the same as positive 315, so that's going to be a -1. -45, we're at the negative slope here. So -45, negative slope. Negative into quadrant 2, when we're in between -90 and -180, we're at a positive slope now. Remember, this is, I probably ought to write it this way, 0, -90, -180, -270, -360. This is going to be this is going to be positive slope, negative slope, negative slope. So I'm at a +1 here between -90 and 180, halfway through here. Now I'm down to a negative again halfway through, and then back up to positive. So notice how my slopes alternate, positive, negative, positive, negative. Now, between each pair of asymptotes, I'm going to have a curve that curves down and then curves up like that. So it runs along the asymptote, curving down till it gets to the x-axis, and then it curves up. Runs along the asymptote, curving down until it gets to the x-axis, and then it curves up. Curves down here. This is the most elegant graph, I think, of all. Just so classic, such a beautiful curve. Really elegant looking. I like the tangent graph. That's probably one of my personal favorites. You might think I'm weird, but that's okay. I can be weird. Now, we're going to deal with domain and range, and domain and range are a little trickier with tangent. Remember Dixie, domain goes with X and range goes with Y. So there we go. Dixie just popped right in there, didn't she? Dixie comes and teaches every once in a while. You'll look forward to that. So I have to think about now what values of X I'm allowed to use. Well, I can use any values of X except wherever there's an asymptote. So I've got an asymptote at -90, +90, -270, and so forth. So what I would suggest you do for right now is just to say, for the domain, is just to say all real numbers, and I'm going to write this as negative infinity to positive infinity. You can also write it as the all real number symbol, or you can say all real numbers. Those are three ways to write it. You don't have to do all three. I'd like you to start using the negative infinity to positive infinity, except for asymptotes. Okay, all real numbers except for asymptotes, plus or minus 90, 270, etc. The range, now, what y values? Okay, what happens right here? Does the slope ever stop? Is there an ever upper limit to how steep the slope can get? No, the closer it gets to 90, the steeper it goes. It just keeps getting steeper and steeper. It gets infinitely steep. So the range can go up to positive infinity, this direction. So positive infinity, that's very poorly written. Let me try that again. So positive infinity, it just keeps going, or negative infinity, it just keeps going. So we can say our range goes from negative infinity to positive infinity, or all real numbers. Now the third thing that we looked at was the period. How many units does it take on the x-axis until the graph repeats itself entirely? So if we look here, it goes from negative 90 to 90 is one section, and then it repeats itself again from 90 to 270, and repeats itself between negative 270 and negative 90. That is a period of 180 degrees. So every 180 degrees it repeats itself. So it has a period that is half as big as sine and cosine.